Now, the next section is going to cover database types. Okay, so on the left side, we have relational or SQL databases. These databases store data in a highly structured and tabular format using rows and columns. Examples of these include MySQL, which is one of the most popular open source relational databases, PostgreSQL, which is known for its features and compliance with SQL standards, Oracle, which is used extensively in large-scale enterprise environments, SQL Server from Microsoft, often used in businesses alongside the software suite that Microsoft provides, Amazon RDS, which is a managed service that supports several relational database engines, and BigQuery, which is Google's fully managed data warehouse that uses SQL queries. On the right side, we have non-relational or NoSQL databases, which are designed for flexibility and scalability. They usually manage data that doesn't necessarily fit well into tables, such as semi-structured or unstructured data, which we talked about in a previous section. Examples of these databases include MongoDB, a popular document-oriented database that stores data in JSON-like documents, Cassandra, which is used for handling large amounts of data across distributed servers, Redis, which is an in-memory key-value store used for caching and real-time analytics, Amazon DynamoDB, fully managed by AWS. It has fast performance and scalability, and Cloud Bigtable on GCP, which is Google's NoSQL database designed for large analytical and operational workloads. So this categorization between relational and non-relational highlights the different needs that they serve. Structured relational data versus flexible, scalable, and often schemaless data management. These are the two main categories of databases that you should know about. Let's talk a bit more about relational databases. First, the visual at the bottom left is a table with rows and columns, and it represents how data is structured in a relational database. In a relational database, we store information in tables that are organized with columns defining data attributes and rows representing individual records. This structured approach ensures that data is highly consistent and easy to access through queries. Relational databases are highly structured and standardized, relying on predefined schemas that determine the layout of each table and the types of data they store. They contain rows and columns, with the columns defined by the aforementioned schema. This consistency is key to maintaining data integrity and consistency. It's ideal for applications where accuracy and relationships between data are crucial. So on the right side, you can see examples of these databases in GCP, like BigQuery, which we already talked about, Spanner, and Cloud SQL. These services help manage data in a relational, highly organized manner. And so it provides data analysis capabilities as well as operational reliability, especially in the case of Cloud SQL for the latter. All right, now let's start talking about non-relational databases. Let's start by taking a look at a couple of visuals to get an understanding of the different types of data models used in non-relational databases. On the right, we have an example of a data model that would not neatly fit into a fixed schema. It's called a graph network. And this type of model is excellent for representing complex relationships between entities, especially where there are multiple types of entities. So you can imagine a social network where nodes represent users and edges represent the connections or relationships between them. In a graph database, these kinds of connections can be stored and queried efficiently. And so this type of structure, which does not fit neatly into tables or rows, would be better served by a non-relational database. It's inherently about relationships rather than a fixed number of columns. And so a schema would not necessarily play well with a graph data model. And below we have a key value store example. So here data is represented as a collection of key value pairs. For example, the key user ID underscore 1234 maps to a value that contains user details like name, age, location, and then another key, user ID underscore 5678, maps to a completely different value, preferences, which itself has a dictionary-like object within it with its own fields. So notice how the data under each key is completely different in structure. Some keys have detailed personal information, others only have user preferences. In a relational database, this kind of inconsistency would be difficult to handle because every record needs to adhere to the same fixed schema. So key value stores are used precisely because they provide this flexibility when different records need different types of information. This is actually also an example of a document store model. It's similar to key value, but allows more complex nested structures, and it's great for handling data represented in formats like JSON, if you're familiar with that. The value in this case is a structured document containing nested fields like preferences. A document store type of model allows you to store entire documents, each of which can have different fields, providing even more flexibility. These examples help illustrate why non-relational databases are so powerful. They're designed to handle unstructured or semi-structured data, so data that doesn't fit well into the rows and columns of a relational table. And so non-relational databases provide flexibility for evolving or significantly varying data models. So to summarize, non-relational databases are ideal for storing and managing large volumes of data that do not fit into a typical tabular format. They can more easily handle a variety of data formats, whether it's semi-structured or unstructured data. The data model flexibility includes document stores for complex nested structures as shown below, key value stores for diverse types of data associated with the unique key, again, as shown below, and which document store is actually a subset of. Column family models for wide column databases, and graph models, which we looked at on the right, which map out relationships, complex relationships effectively. So this kind of flexibility allows non-relational databases to excel in use cases where schemaless storage and scalability are really the key factors. Non-relational databases allow you to scale effortlessly by eliminating the need to redefine the entire schema whenever data evolves. So this makes it easy to accommodate growth as well as changes in your data structure. Lastly, on this slide, we are comparing relational and non-relational databases in terms of their pros and cons, just to sort of drive home a better understanding of the differences between them and kind of when to choose each. Let's start with relational databases. The pros include standardization. Relational databases are common, and they use a standardized query language called SQL, which is widely adopted and understood. They are the go-to choice for analytics and data science, that especially those tasks that need structured data and are in need of complex queries. ACID compliance is another strength, ensuring consistency and reliability for things like transactions. And so that's generally more common among relational databases than among non-relational databases. However, relational databases also come with some downsides. They can face scalability challenges when data size grows significantly. They struggle with semi-structured or unstructured data, obviously, because that doesn't fit neatly into tables. There's also the rigidity with the schema, which makes changes to the data structure cumbersome. If we talk about non-relational or NoSQL databases, the pros include, in contrast, excellent scalability, particularly for distributed systems that need to scale out horizontally. We'll talk about the difference between horizontal and vertical scaling. later as well. Flexibility in data models, which allows you to store various types of data without rigid schemas. They're also well suited for big data applications. So related to the scalability question, they're efficient for handling very, very large data sets. And higher performance is often achieved with these, especially for reads and writes at scale. Now, the downsides for NoSQL databases include a lack of standardization, which means that there isn't a single query language like SQL, so that can make querying less straightforward, and it can create a learning curve. Non-relational databases are often less ACID compliant, which means you might trade off consistency for scalability. Analytics and reporting can also sometimes be more challenging because of the lack of a rigid structure, which makes aggregations more complex. So each type has its own strengths and weaknesses, and the right choice will just depend on the use case, whether you need the rigidity and transactional consistency of relational databases or the flexibility and scalability of NoSQL databases. So keep that in mind as you're learning about the different GCP services in the rest of the course and as you're answering exam questions. That's it for the section on database types.